Good morning everyone. I am Ayush. I have done my BTech from PICT Pune. Now today we are going to learn about SHM, that is simple harmonic motion. So before starting this lecture, I want everyone to look in the basics of mechanics such as Newton's laws of motion, work per energy, then system particles and rotational motion, center of mass. So if you have a good grasp on this chapter, you will get a very good grasp on SHM. Otherwise, everything would go from the top of your head, right? So now, SHM का मीनिंग क्या है? SHM को आप simply ऐसा समझ सकते हो that a particle who does a to and fro motion about a point is known as SHM. Now I will demonstrate some examples and make it feel very easy to understand. So before starting the main SHM, we need to study mainly three types of motion. So first motion is periodic motion. Second type is oscillatory motion. Third type is harmonic motion. So ये तीन प्रकार है जो बहुत इंपॉर्टेंट है. These three are very important, right? Now let us start with this first, periodic motion. What is a periodic motion? Any motion, write it down, any motion that happens after a certain period of time. Any motion that happens after a certain period of time. Let's suppose there is an imaginary ant here who climbs a certain distance of height, here, and then falls again here. Again climbs, again falls. Again. This process goes to infinite. So there is a period, right? It is a periodic motion. How? The ant is going up, again falling, and going up, again falling, going up, again falling. So this is a periodic motion. So just see a graph, so you will have a good understanding of periodic motion. So now this is a periodic motion. It is repeating after some right, it is t, 2t, 3t. So it is a periodic motion which is repeating itself after t seconds. So it is which is repeating itself after t seconds, right? So this can be known as periodic motion. जो चीज कोई भी x समय के बाद रिपीट होती है उसे हम क्या बोलते हैं? पीरियोडिक मोशन. ठीक है, चलिए अभी अगला मोशन के बारे में बात करते हैं. Let's see the second type of motion, that is oscillatory motion. What is oscillatory motion? This is very important, right? Oscillatory motion. Now, oscillatory motion, I can call it a periodic motion, but the only difference between oscillatory motion and periodic motion is oscillatory motion has a fixed point about which it do to and fro motion, right? So suppose here it is the point. So it has a fixed point. This is a fixed point, right? This is a fixed point. This is a fixed point about which it is doing the motion. So we can say that oscillatory motion. So we can say that oscillatory motion is nothing but it is a periodic motion which is finite and bounded, right? I can tell that oscillatory motion is bounded around some boundaries. Okay, now there are some terms which is used both in oscillatory motion and in SHM, so I will explain it here. It has a mean position, right? This position is known as mean position. Mean position is what? It is a position where the particle does to and fro motions, right? So this is a position with respect to which particle does to and fro motion. So I can therefore tell that it is a mean position. The extreme ends, so from this is and this, so these are known as amplitude. What is this known as? Amplitude. This is known as amplitude. What is amplitude? It is the distance between the mean position and the extreme end of any particle who is doing oscillatory motion. That is amplitude, right? Okay, now let us start with harmonic motion. harmonic motion. I'm not going to go in depth with the harmonic motion. Just what is a harmonic motion? Anything that can be represented in single sine or cos function is known as harmonic motion. So suppose this is the sine omega t. So this is a harmonic motion because it is just a single sine function. Now this is 2 cos omega t or 2 times omega t. So we can say that this is a simple harmonic motion. Not simple harmonic motion, this is a harmonic motion, right? Okay. Now we will move to our chapter, that is simple harmonic motion. So how can we tell that an object is in simple harmonic motion? Now write it down, that is very important. If any particle does to and fro motion and has a tendency to come back to its mean position or original position, it is known as simple harmonic motion. Simple harmonic motion is कोई भी पार्टिकल उसके मीन पोजीशन पे आने की क्षमता रखता हो या मीन पोजीशन पे आने की चाह रखता हो, उसे हम क्या बोलेंगे? SHM. That is doing some SHM and some necessary conditions should be fulfilled for that SHM, right? Because whatever I am telling, that was also done in oscillatory motion, but what is the difference between SHM and oscillatory motion? I will write it down. So this is the mean position, right? And the particle is doing to and fro motion about this position. Okay. What is happening? Particle is यहाँ पे particle and we have given a push acceleration A to the particle here, right? Acceleration A. Now we have given the acceleration. We have given not acceleration. We can tell that we have given velocity, and particle is reaching here. And now here velocity should become 0, and particle should again go to the desired mean position. This is our desired system for SHM. Again here should be velocity 0 and particle should go in this direction. So this is SHM. So the basic condition for the SHM is that acceleration, what is acceleration, should be directly proportional to negative of displacement in vectorial form. Now this is very easy to understand. If the particle is here, particle wants to go in this sort of displacement. This is displacement. This is displacement that particle wants, right? But what will happen here? That acceleration would oppose the displacement. So the net force in this direction. Oh, so net force in this direction. So there was some velocity. Now net force is in this direction, so acceleration is direction, so velocity would reduce and velocity will certainly become 0, and then again the particle will go here. Same here, the particle wants to go here, but there will be force which is opposing the displacement. So the force is this, so there would be acceleration would be in the direction of the force, so velocity will become 0, and once velocity becomes 0, so acceleration would again make velocity generate velocity, and it would throw the particle to mean position. Okay, so this is why we need acceleration should directly be proportional to negative of displacement, right? Now let us know the chart of SHM, right? What is the chart of SHM, or what is the graph of SHM? Now this is the mean position. Okay, I am just dividing this in this graph, or you can do this. Yeah, this is, I think this is fine. I have given the particle a velocity v, right? I have given the particle a push v, velocity v. Now the particle is going. So yeah, so when the particle is going here, so velocity is decreasing. Why? Because acceleration is in the negative direction of displacement. As particle is going here, so displacement is increasing and acceleration is also increasing, but in the negative direction of the displacement. So velocity should decrease and acceleration should increase as the distance is increasing. Okay. Now here velocity, what is here? Here velocity is 0 and acceleration is in this direction, right? Now in this quadrant, what would happen? Now acceleration is this direction, velocity is also in this direction, so velocity will increase, but acceleration would decrease. Why acceleration would decrease? Because x is decreasing. Same reason. Now here velocity will decrease and acceleration will increase, and same here velocity will increase and acceleration will automatically be decreased. Okay, this is the basic thing that we do in SHM. So these are the four quadrants and these are the relationship between velocity, acceleration, velocity and acceleration. Okay, yes. So just so velocity will increase and acceleration will decrease. Okay. Now let us remove the constant from acceleration term. Okay. Now I told you that acceleration should be directly proportional to minus of x, right? When we remove this, we get acceleration as equal to omega square x. I can prove this. Why it is known as omega square? It is the solution of differential equation. We get the omega square. Okay. Now, so now I can therefore write what is force. Force is mass into acceleration. So force can be written as what? M omega square times x negative direction. Okay, m omega square x in negative direction. Now this so f is equal to what? Minus kx. So this k is equal to what? M omega square. So k by m is equal to omega square, and we all know, I am continuing here, we all know that omega is equal to 2 pi by t. So time period should be equal to what? 2 pi by omega. And what is omega? Omega is under root of k by m. So t equal to 2 pi under root m by k, where k is known as force constant. Okay, so k is known as force constant. So this is the time period of SHM, that is 2 pi under root m by k in a block system. Because time period will vary in the earth pendulum system, the time period will be some different. In block system, it would be different. In spring system, we need to take the equivalent of this k, so that would be different. So this is the main basic things of SHM that we need to know. So next we will study about the phasor diagrams in SHM, then about the hinged SHM, then torusal, then we need to study about the angular SHM, and there are a lot of things we need to study. So thank you for watching it.